Hello, this is Dr. Vahid Aryadust here, and I'm delighted to demonstrate how to use Winsteps for a quick analysis of your results, of your data. In a few previous videos, I have discussed how to use Winsteps for different purposes. So this demonstration aims to provide a quick and effective way of analyzing your data using Winsteps or Rasch measurement, which is a software program for Rasch measurement. If you have not downloaded Winsteps, you can either download the trial or student version, which is called Ministeps, from this website. I'll try to provide the link for you in the comments section below the video. Please feel free to download it. With this trial version, you can analyze 25 items and 75 students or cases. But if you would prefer to purchase the full version of the software, you can actually analyze 60,000 items and 10 million people. That's really a huge number. I personally do not think that in real world situations we will have such a large test, but in some cases where you have done you want to do linking and test equating, you might need the full version of the software package. So I would like to start off by explaining how you can create an input file for Winsteps. So I have the full version of Winsteps package here. I'm going to double click on it. The version that I'm using for this demonstration is version 4.5.5 at this time, which is July 23rd, 2020. This is the latest version of Winsteps. Okay, so in order to create an input file, you need to open Winsteps. You need to click on Excel and RSSST, which represent different data files which Winsteps can read and convert to a text file. So this little window pops up. In other versions, you might already get this without having to click on this button. So as soon as you see this window, you need to find the file that you have prepared. Here I'm going to demonstrate how to do this for SPSS and Excel, which I have already prepared in this folder, as you can see. So let's get started with SPSS. Actually, here is my SPSS file just to show you how it looks like. I have three person variables here, which stand for the number or the ID which has been associated with every test taker. I have a gender variable which is in string format in SPSS. In other words, it has got words rather than associated numbers, and I've got gender recoded. Therefore, for female, I've got number 1, which is actually a nominal variable, and number 2 for males. And this is the variable view of the data if you're interested to look. For items, I have question 1 all the way to question 32, and I'm going to toggle back to data view to show you that these are my data and or items from question 1 all the way to question 32. So I'm going to go back to my Winsteps and open the same file which I just showed you. So click on SPSS and this window pops up. Then select SPSS from the left corner, and then I need to find my folder, which is right here, and this is the data file that I need to open. So I click open, and that's it. So I have read my test data file, the SPSS file, into the conversion menu of Winsteps. Now if I scroll down, this is the most important part. We will see 3 lines in red. Here is a warning message for us: do not delete this line. Do not delete this line. It's actually important not to delete them, therefore. So we have 2 groups of variables, as I showed you before. One is item response variables, the other one is person label variables. And to help you create an association between these and the SPSS file, which I already showed you, I toggle back to SPSS. So my item response variables are items number 1 all the way to 32 here, and my person label variables are number, gender, and gender recoded. And you can also see them right here. So this is gender recoded, this is gender, and this is number. The same thing is right here in the SPSS file. So what I need to do is to either copy and paste or drag and drop these rows under these two rows. So I would like to start with person level variables. I have already highlighted them, and just drag and drop or copy and paste. It doesn't really matter. If you drag and drop, it's like cut and paste. So you cut it from here and you paste it there. I'm gonna hit Control Z to undo whatever I've done. I want to show you that you can also do copy and right click, and here, right here, right click, paste. So if you do copy and paste, these variables will still be visible there, but other than that they will disappear, which doesn't matter really, because Winsteps later reads these two lines, two sections or two blocks of information. So if you delete the rest of them from here or anything else from here, that will be fine. It will be ignored by SPSS, by Winsteps. Now let's say you don't want to include numbers, so you just delete it. So your Winsteps file is going to only include gender and gender recoded, which is fine. I'm going to hit Control and Z to get back number, because I want to have the number there. It's really some sort of useful information. Now I want to put my items as well under item response variables. I have all the items starting from question 1 or Q1 to 232, which we saw from the variable view is question 1 to 32. So let me go back. I'm gonna copy everything from the bottom or the top, which doesn't matter. Okay, so it's copy. Again, the same thing. I can drag and drop. I can Control and X, which is to cut them, and paste it under item response variables. I usually just drag and drop. So I drag it and drop it under item response variables, and there you go. I want to check before I hit the construct Winsteps file. So you see question 1 all the way to question 32 all are included under my item response variables. Now you might, in other scenarios, you might want to delete some of these items because for some reasons you don't want them to be in your file. That's fine, and you can just remove them. For example, I can remove question 11. That's it. So SPSS will not include question 11 in the file, but for this analysis I need that, so I'm going to hit Control Z to get it back. For my person label variables, I have those three variables which I've already discussed. I think that's more or less everything that we need to include in this analysis. The rest of the information here will not be read by Winsteps because, as I have discussed in another video, whenever you've got semicolons, Winsteps and also another software package called Facets do not read anything to the right side of the semicolon. So these are not read at all by Winsteps. So now construct Winsteps file. That's the only thing that we need to do at this stage. Okay, click that, and it's actually the folder where I want to save my file, and I'm going to call it Rasch analysis. Yes, and click save. There we go. So all sort of information that we need to check is here. The SPSS cases processed consists of 500 students or test takers, and yes, if I go back to my SPSS file and scroll down, you will see that I have 500 students or 500 test takers. That's exactly right. So we need to check these actually to make sure that our data has been converted correctly. SPSS variables processed 35. It is 35 because 32 items here, as you see, 32 items were there in the data file and 3 variables for persons. So that makes a lot of sense here for us. Now, I think the rest of the information is fine, so I'm not going to go through this. These pieces of information are, usually fine because if you have done the previous stages correctly, which I went through, so these pieces of information are correct. So the only thing that I would like to stress here is to ask you to check the codes, because if there is a code here which is not supposed to be there, then the whole analysis can be affected. I have 3 codes: a dot for missing values, zeros, and 1. So if a person missed an item, he would receive a 0, like for example this person who's a male who missed this one, who's a male who missed question number 1, so who received a 0. And if they answered correctly, they would receive a 1. So that's a 1. That there are samples of 1. And these are the 3 variables which I have already mentioned. Those 3 person variables: number, which is here, gender, which associates with this gender, and gender recoded, which is connected to this one. That would be it. Then I also need to go through the list of the items just to make sure that everything is there. So item 1 or question 1 all the way down to Q32 or item 32. Make sure that these two correspond to each other. And here is my data. This part is represents items number 1 to 32. This is my first person variable, or their ID. As you see here, they're in 3 columns, 1, 2, and 3, because I have 500 people, so it gets up to 3 digits. Then gender, which is gender, and gender recoded, and gender recoded is here. So everything is in good order, and I'm going to close this, and I'm going to go back to the Winsteps file. I'm going to also close this. I don't need this anymore, so cancel end or just close. And my SPSS file is open. Winsteps is open. What I can do is to read this file which I have created from open files. But I always, for some reason, I like drag and drops. I always drag the input file which I created, that I just showed you, and drop it into Winsteps. And there we go. So Winsteps is going to read it for me. I'm going to press enter, and it asks me extra specification. No, I don't have any extra specification. I'm going to hit enter once again. There we go. So the analysis is done. Now, before I go through these statistics and tell you how to read them quickly, what I would like to continue with is to show you how we can also create an input file for Winsteps from Excel sheets. I've already created 2 Excel sheets. What I would like to show you is these 2 Excel sheets are almost exactly the same, with one exception. So this is Excel sheet 1, and this is sheet 2. As you see, sheet 2 has got 2 tabs: tab 1, which is empty, tab 2, which includes the actual data that I want to analyze. It's exactly the same as the Winsteps, the SPSS file that I just showed you. For the second one, here, this is still the first one. For the second one, we only have 1 tab. Okay. What I would like to stress here is, when it comes to converting Excel sheets into input files for Winsteps, it would be important for us to park the data in the first tab. In this case, my data is in tab 2, not in tab 1. So tab 1 is empty. So let's check out what happens if I go around if I start converting the data from this Excel sheet, where the data has been included in tab 2. I'm going through the same procedure again. I'm going to click Excel and RSST. Okay, we got it. So Excel. and select Excel file. All right, nice. So tab 2. Tab 2 is this one. Remember that the data is parked in tab 2, not in tab 1. Okay, so click open. So it's processing it. Actually, yeah, you see, the action cannot be completed because the other, oh, sorry. I think I should close this first. Okay. Right, so the action is completed. But in tab 1 of the Excel sheet that I just showed you, there is no data. So this means that, at least in this version of Winsteps, the only thing that's read is the data parked in the first tab. So I want to stress that if you want to read your data from Excel sheets, it's important that we park them in the first tab. So I'm going to rewrite or overwrite this part of the analysis by going back to select files and select the tab 1 data, where all the data has been parked in tab 1. So it's going to take some time for this analysis to start. Yes, okay. So as you see, the data has been read. It's exactly the same thing and exactly the same procedure as a result. So I will copy and just drag and drop, and also highlight these, drag them and drop them under person labels, because these are my person labels and these are my item labels. And in the same way I will construct Winsteps files. Yeah, it's a bit slow today. Okay, here we go. And you can actually call them. So I'm gonna call this Rasch analysis Excel or EX for Excel, and save it. So what I would like to show you is that the file that is being created is almost exactly the same, with the exception of the name or the title from which the title of the original data set. So the rest of the story is exactly the same, as you see. Yeah, so I just wanted to check again that the codes are 0 and 1. So that missing code has been replaced by 0. So you don't see any missing data here. Oh, it hasn't been replaced by 0. Actually, it has been replaced by an empty space. I see what's happening here. You see there is an empty space here. We cannot see it unless we highlight it. Yes, the empty space there, which stands for missing data. So wherever we have an empty space, I think, which is not difficult to find now, it indicates that there is some missing data there, which means that the students didn't attempt to answer that item. Okay, so I'm going to close this, and go back to the analysis. I've already run the analysis on this file, Rasch analysis. What else do we need to do for our Rasch analysis, and what should we take into consideration? 3 things, generally speaking: reliability and separation for items and persons, item and person fit statistics, unidimensionality, and local independence. Now, for this demonstration, I'm not going to go through a lot of details because I have already explained these in separate videos. But I think since it's meant to be a quick and effective video, I'll just provide some useful information, some maybe basic and useful information about examining those statistics. First of all, as I mentioned, reliability analysis for persons and items. This table shows, presents the reliability results. For persons, we have a reliability of 0.86. Whenever the reliability analysis, the coefficient is larger than 0.8, we have a separation index, usually greater than 2, which is good news most often because it indicates that persons are different and there are at least 2 levels of ability that have been differentiated by our measurement among our test takers. So this is good news for us. And also the overall amount of error of measurement is not extremely high. So we have 86% of confidence about the measures of persons. The interesting thing is that our confidence about the measures of items is much higher than that for persons. It's about 97%. And this indicates that there are around 5.96, let's say 6 different levels of difficulty in the test items, meaning that you can differentiate between 6 levels of test items in terms of difficulty. The other thing that we need to take into account is the fit of items and the fit of persons. I just right-clicked on the interface of Winsteps. Anywhere you right-click, you get this. You can also get the same menu from output tables. It's exactly the same thing. So what I would like to see is how my items are functioning. So I'm going to order my items based on their fit statistics, and here you go. They have been ordered not based on their running order, but based on their fit statistics. We have two groups, infit and outfit. This one is sensitive to inliers, and this one is sensitive to outliers. To be more specific, sensitive to aberrations among the inliers, and this is sensitive to aberrations among the outliers or outlying data. There are different schools of thoughts how to look into these, and I will actually explain that in a separate video. We have recently published a comprehensive paper on Rasch measurement, a comprehensive review of Rasch measurement in language assessment, and we have recommended some suggestions or perhaps guidelines how to interpret these fit statistics and how to report them. In a separate video I will go through that, and I think there is a little bit of details there. But as a rule of thumb, for multiple choice questions, if the tests are high stakes, let's say the present test is a high stakes test, a value between 0.8 to 1.2 for infit and outfit statistics would be productive and useful. But if infit and outfit mean square values fall outside of that, then you should actually inspect why those items are functioning like that. Luckily for us, all infit statistics are fine because the largest one is equal to 1.17, whereas the smallest one is 0.81, which is pretty good. For outfit, however, we have a slightly different pattern here. As you can see, these items are larger than 1.2, and actually I would say especially these three, maybe these two items here kind of pass the test of fit. Really not a big challenge here for item 27 and item 20. But for these guys, item 5, 3, and 13, I would say it would be a good idea to look at the data closely. So let's look at the data closely. I'm going to scroll down to go to table, here table 10.4. This table is useful because it shows the most, sorry, I have to scroll down again. It demonstrates the most misfitting persons in the data. So the most misfitting persons are here, and they have also been arranged based on their ability level. So the first person, we have to read these vertically in this way. So the most misfitting person, the most able person among the most misfitting persons, if that makes sense to you, is number 491. So person 491, whoever that person is, performed on item 5 in this way. He was fine for item 5 actually, because whenever you have a dot, it means it was fine, the performance is expected. But whenever we have anything other than a dot, it means that this performance is not expected. So he provided a 0, meaning that he missed that item. It's not a questionnaire, so actually it's better to say that he missed that item, so he got a 0, which means it's not what we expected. So we'd expect him to have answered that question correctly, which he didn't. And the rest of the performances for this person are fine, but when it comes to the second person, that's person 487. He performed erratically on item 20, as you can see. So I'm going to highlight it for you. Item 20, this, no, actually, sorry, this is not true. He performed unexpectedly on item, this one, because this is the second person, item 24, right? And you can actually go through the rest of the story in this way. There's another useful table here, and the reason why I don't explain this in more detail than this is that because I have discussed this in other videos, I will make sure to leave the links to those videos that I have already created in the comments section. But this table is very useful because you know, these this way of visualization is also helpful. But if you're not interested in reading this visual, what you can do is just to go to table 10.6 and find out who has been answering the questions unexpectedly and why. For example, for person number 216, person number 216, his performance on item 5 was unexpected because he missed it, whereas the expectation was 0.99. That means almost 1, right? So we expected, I mean, the model expected that this person would answer the question correctly, whereas he missed it. For the second person, who's a female, number 24, the same thing happened. She answered it incorrectly, answered question 5 incorrectly, but you know, she should have answered it correctly. Do we have other unexpected values for item 5? No. So oh, here, item 5, yes, this one, that one. Oh, you can find out how many people answered the item unexpectedly, and if it's a large amount, meaning something around 2% of people answered that item unexpectedly, then you need to make some remedies to the item. If there's a large amount, like 10% of people answered it incorrectly, which would affect the fit statistics, then you might have to remove that item from your analysis. Okay, so I'm gonna close this and go back to the output tables. The same thing can be checked for persons. For persons, we have a better profile for infit, but when it comes to outfit, I'm afraid the profile deteriorates here. So you might want to go through the profile of the profile of these people to see why they have performed unexpectedly on those items. So let's close this and look at the criteria that we want to check again. Now we want to check unidimensionality and local independence. Again, I have discussed this in separate videos, but just a quick reminder. Right click, go to item, dimensionality, and do not check this one really, just click OK, because that will output another output file in the form of an Excel sheet. So a quick look at this table here shows that our data is most likely unidimensional because the unexpected variance in the first contrast is 1.6, which means there is almost one item or one unit in our measurement in the first contrast. A contrast is a kind of dimension that wasn't explained by the Rasch dimension. It's a dimension beside the Rasch dimension, in other words, and which is found in the residuals of the data. So the residuals of 1.6 items, not even 2 items, form a structure together. this is not substantive enough to be called one dimension, and therefore I think this analysis provides evidence that our data is most likely unidimensional, not to mention that the raw variance explained by measures is 13%. So this is almost between 12 and 13 times larger than the raw variance that is explained by the first contrast. That's another piece of evidence. So you need to compare this and this. But there is no criteria as to how much this amount of variance should be so that the data would qualify as a unidimensional data. But overall, I should say that there is a huge difference between the amount of variance that is explained by Rasch measurement, the Rasch measurement dimension, and the dimensions that were found in the contrast or the residual. So you can go to the rest. As you see, these items are spread all over. We don't have separate groups of items. For example, one separate group here, which would be standing out from the rest of the items. So this also provides me with enough evidence and information that my data is unidimensional. For local independence, just within the same output, you just scroll all the way down to the last table, which is 23.99, and look at the correlations of the residuals. This is also known as Q3 coefficient, which is most commonly, the term Q3 coefficient is most commonly used in IRT rather than Rasch measurement literature, but I think it doesn't matter really. You can refer to it as Q3. So what happens is the correlation between the residuals of item 18 and item 19 is 0.15, which is not large really. That's below 0.3. So I would say, and same here and same here, regardless of the direction, the absolute value is below 0.3. So I would say that there is evidence that local independence is also established in our data set. Again, I'll provide a link for you to watch the videos that I have created about local independence and unidimensionality and Rasch measurement in Winsteps. So this brings me to the end of this video. Thank you very much for your attention. For differential item functioning, sorry, before I say goodbye to you, for differential item functioning, which is an optional analysis, I have also created videos for that. So I'm not going to go through this because that's why I have mentioned that it's optional. But these three are important for a quick Rasch analysis and also for writing your papers and reports. So thank you very much for your attention. Hope you find the video useful. Have a good day.